Hey everyone! A solid is generated when the region in the first quadrant bounded by this graph, which we're going to call f of x, it's y equals 1 plus sine squared, and the line x equals pi over 2, the x-axis and the y-axis. And all we have to do in this problem for the AB calculus exam is to write an integral to evaluate its volume. So what you need to know is the formula for the volume of a solid revolution about the x-axis using a vertical slice bounded from above the curve f of x and from below by g of x on the interval AB is this formula here. So this is if you know your formula, and this is what the problem is testing, is if you know that formula. So what I did is I went ahead and graphed this part. We're going from 0 to pi over 2 on your x. And then I shifted up the graph by 1 with this vertical shift. And I know that sine of pi over 2 is 1. And so if you do 1 plus sine of pi over 2, and then we square that, well, sine of pi over 2 is just 1. And 1 squared is just 1. So that equals 2. So that gives me that point in here. So this is what we have. So basically, I'm just going to use my formula. Again, I'll write it. So pi b to a, or a to b, f of x squared minus gx squared. So basically, just fill it out. And so you're going to get pi 2, your a is 0, and your f of x is going to be 1 plus sine squared of x, and then you just square it. And minus this one, we're at 0 here, or the vertical slice is at 0. And so that's just going to be minus 0. So this is, we're just left with that. And then you write your dx. And that's it. Thank you. Have a nice day. Bye-bye.